Hello students, this video is about our fifth module, that is compressors. Compressors are used, as that name indicates, it is used to compress the fluid flowing through the machine. There are many types of compressors. First, we will look into the classification of compressors. So the compressors classified as shown in this slide: positive displacement compressors, dynamic compressors, or rotodynamic compressors. In positive displacement compressors, we have already discussed what is positive displacement and what is rotodynamic. There are two types of positive displacement compressors. One is reciprocating and other is rotary. And in reciprocating compressors, again classified or again divided into two: single acting and double acting. Rotary compressors are helical screw type, ring type, scroll type, sliding vane type, and lobe type. Dynamic or rotodynamic compressors are divided into two, which is centrifugal compressors and axial compressors. Okay, here is the classification of compressors according to different criteria. So first one is according to principle of operation. There are two types of compressors. We are first looking in positive displacement compressors. So according to principle of operation, there are two types: reciprocating compressor and rotary compressor. Reciprocating compressor, as you know, it's just like reciprocating pump. The air sucked by the suction stroke and compressed, then delivered in the delivery stroke. That is reciprocating compressor. Rotary compressors, several rotary compressors are there. We will discuss these rotary compressors later. So according to the action, there are single acting reciprocating compressor, and double acting compressor is also there. And according to the number of stages, single stage compressor, multi-stage compressor. In single stage only pressurized in a single stage, in one stage, but in multi-stage we will have more than one stages in a single machine to increase the pressure of the flowing fluid. Another classification is according to the working pressure. Low pressure compressors, it's below 1 bar pressure. If the working pressure is below 1 bar, it is low pressure compressors. Medium pressure, if the working pressure is between 1 and roughly 10 bar, then we will call it as a medium pressure compressor, and above 10 bar, then the compressor is known as high pressure compressors. Similarly, according to the capacity, low capacity, it is around 0.15 meter cube per second volume of air is delivered, then it is low capacity. And between 0.15 and 5 meter cube per second, then it is medium capacity compressor, and above that we will call it's a high capacity compressor. Another classification is according to the method of cooling. See, if you increase the pressure of a flowing fluid, uh, the temperature of the fluid also increases. So uh, uh, we have to cool the fluid. So we will use air as a cooling medium, then it is air cooled compressor, water as a cooling medium, then it is a water cooled compressor. So first of all, we will discuss about reciprocating compressor, how the reciprocating compressor works. See, uh, this is suction valve, delivery valve, this is the piston, this is connecting rod, this is crank. So now the piston at the top dead center, piston is here, there will be a small clearance which is called clearance space or clearance volume. Now it is at the top dead center. This is the position of the piston at the top dead center. Then if the crank rotates, the piston moves downwards, which will create a pressure difference inside the cylinder. Then the inlet valve or suction valve opens, the air suck into the cylinder. See, the air is sucked into the cylinder. At that time, the delivery valve is closed. So this is the condition. Now, if the piston is at its bottom dead center, the suction completes, then it will start compressing the trapped air inside the cylinder. So the trapped air inside the cylinder is compressed by the upward movement of the piston. Then if it reaches a particular delivery pressure, the delivery valve opens and the high pressure air flows out of the cylinder. So this is the working of a reciprocating compressor. So these are the terms, some terms used in analysis of reciprocating compressors. First one is suction pressure. It is the absolute pressure of air at the inlet of a compressor, and it is denoted as P1. That is, V starts with 1, state 1. Next one is discharge pressure. It is the absolute pressure of air at the outlet of the compressor. Then compression ratio or pressure ratio, it is also called pressure ratio. It is the ratio of absolute discharge pressure to the absolute suction pressure. And it is denoted by small r. And we know that the discharge pressure or delivery pressure always more than the suction pressure. Then the compression ratio is always greater than 1. Now next term is stroke volume or swept volume. It is the volume of air sucked by the compressor during its suction stroke. Next, compressor capacity. It is the volume of the actual amount of air passing through the compressor in a unit time. This is compressor capacity. It is expressed in terms of meter cube per second, volume flow rate. Then another thing is clearance space and clearance volume. See, what is clearance space is when the piston reaches the top dead center, then there is a small clearance between the piston, top of the piston and the cylinder head. This space is called clearance space, and the volume occupied or volume of that uh, occupied by this space is called clearance volume. The next one is clearance ratio. It is uh, the ratio of clearance volume to the swept volume, which is called clearance ratio. And volumetric efficiency is is the ratio of stroke suction volume to the stroke volume or swept volume of the cylinder. Next is the work done by a single stage reciprocating compressor without clearance volume. So first of all, we will discuss without clearance volume. Then we will go to with clearance volume. Okay. So this is a PV diagram of a compressor. This is the suction stroke, constant pressure suction, and this is compression. The compression could be isothermal or polytropic or an isentropic process. And after the compression, there will be a constant pressure delivery stroke. Okay, so this is the cycle of a reciprocating compressor. So first we will discuss the isothermal compression. So if isothermal compression, this is the compression path. For polytropic, it will be this, and for adiabatic, reversible adiabatic or isentropic, this will be the compression path. Okay. Now, first of all, we will discuss about the isothermal compression or work done by a single stage reciprocating compressor with isothermal compression. So let's assume this compression is isothermal. We know the governing equation of an isothermal process, which is PV is a constant, pressure into volume is a constant. So the sequence of operation, the suction is, this is this naming is not correct. So this is 4, this is 1, this is 2, this is 3. Okay. Suction process from this to this. Okay. The sequence of operation is the suction process 4 to 1, 1 to 2 is isothermal compression, and 2 to 3 is constant pressure delivery. Now we know that the work done is the area bounded by that curve, which is equal to compression work, delivery work minus suction work. And since this process is a compression process is isothermal, then the isothermal work done is equal to P1 V1 ln of V1 by V2, and delivery work and suction work are constant pressure processes, so they are integral of P dV. It is P2 V2 for delivery and P1 V1 is suction. Now substitute the expressions in our work done equation, we will get this. See here, for isothermal process, PV is a constant, that is P1 V1 is equal to P2 V2. Then this term becomes 0. P2 V2 minus P1 V1 is equal to 0. Then work done is equal to for a isothermal compression compressors, work done is equal to P1 V1 ln of V1 by V2, and PV for ideal gas is equal to MRT. So P1 V1 is equal to MRT1 into ln P2 by P1. So what is P2 by P1? P2 by P1 is nothing but the compression ratio. So compression ratio is R. So work done is equal to MRT1 ln of R, where R is the compression ratio. So next is polytropic compression. See, the equation for polytropic process is PV raised to N is a constant. Okay. All these things are same. 4 to 1 is suction, 1 to 2 is compression, 2 to 3 is delivery. Here the only difference is, for a polytropic process, the work done is equal to P2 V2 minus P1 V1 divided by N minus 1, where N is called polytropic index. You have studied this in your thermodynamic course, so I don't want to explain all these things. Okay, so this is the work done in a polytropic process. So substitute this work done in our equation. This is the work done by the compressor equation. It is compression work plus delivery work minus suction work. So substitute this here. Then we will get this expression, work done, or W is equal to P2 V2 minus P1 V1 divided by N minus 1 plus P2 V2 minus P1 V1. Okay. So if you expand this, multiply N minus 1 with P2 V2 and P1 V1, then expand those terms, and finally we will get a nice expression like this. W is equal to N by N minus 1 into P2 V2 minus P1 V1. And in terms of universal gas constant, characteristic gas constant, then it is W is equal to N by N minus 1 into PV is equal to MRT. So MR is common for P2 V2 and P1 V1. MR into T2 minus T1. Now, if you taking this T1 outside, then we will get W is equal to N by N minus 1 MR T1 into T2 by T1 minus 1. See, for a polytropic process, T2 by T1 is equal to P2 by P1 raised to N minus 1 by N. So substitute thus that value, then finally the expression is W is equal to N by N minus 1 into MRT1 into P2 by P1 raised to N minus 1 by N minus 1. This P2 by P1 is compression ratio R. So this is the expression for work done in terms of compression ratio. Similar to polytropic process, in isentropic or reversible adiabatic compression, the equation is PV raised to gamma is a constant. The only difference is, instead of N, you write gamma. So W is equal to gamma by gamma minus 1 MRT1 into pressure ratio or compression ratio raised to gamma minus 1 by gamma minus 1. Same as the polytropic process. The only difference is, instead of N, this is gamma. So this is the work done uh, by a compressor which is operating, or the compression process is an isentropic one. Okay. In next class we will do some problems on this part, single stage reciprocating compressors, covering all these three compression processes. Thank you.